So we're now going to look at Lewis diagrams. And something that Lewis diagrams are oftentimes referred to as well is what's called just electron dot diagrams. And the reason we call them that is because we're just using dots to represent electrons, and we're making diagrams out of those. Now, in the previous video, we talked about Lewis symbols. And one common mistake that kids like to make is they like to try and use the Lewis symbols to build the Lewis diagrams. And it's kind of the opposite to that, if it can be really considered that, I guess. Essentially, what you need to kind of look at it as is you need to follow the rules for drawing Lewis diagrams, draw the Lewis diagrams, and then we use the Lewis symbols of the atoms that are involved in that diagram to kind of confirm whether our diagram is what it should be. And so I'll show you how that kind of works. But be careful that you're not using the Lewis symbols to draw the Lewis diagrams. We're drawing the Lewis diagrams, and then we are going to use the Lewis symbols to kind of confirm what we have to make sure that it's fitting what we know about those atoms. So I'm not going to have the rules up here on the board. I've put those rules in the video description down below, so if you want to take a look at those and jot them down in your notes so that you can then follow along in the video, that would be great. But I will go through the rules here verbally as I kind of draw these diagrams for you guys and go through a variety of examples to sort of illustrate how each rule works and the order in which you need to do these rules, because the order does really matter. So the first thing that we need to do when we're drawing Lewis diagrams is you need to just count up how many valence electrons we have to work with all the atoms that are involved in this diagram. So you can see in this diagram I have one carbon and I've got 4 hydrogens. Well, I know that one carbon will contribute 4 valence electrons to us making this diagram, and hydrogen will contribute 1. But because I've got 4 hydrogens, I've got 4 ones, so I've got 4 more valence electrons. Add that up together, and the total number of valence electrons that I have to build this diagram is going to be 8. Remember that you're not counting up how many total electrons these atoms have. For bonding, all we care about are the valence electrons. So carbon's found in group 4, it's got 4 valence electrons. Hydrogen's found in group 1, it's got 1 valence electron. And so we add them up like that. Now, the next step or next rule that you need to do is you need to identify out of these compounds and these chemical formulas what is going to be the central atom in this diagram. Now, there's a couple of sub-rules that you need to be aware of. First and foremost, if carbon is present in the molecule, it will always be the central atom. Carbon can never be on the outside of the diagram. It always has to be in the middle. A couple other rules that kind of help you in choosing what the central atom is that hydrogen can never be a central atom. We never find hydrogen in the middle. It's always on the outside. So that makes this diagram really easy. Hydrogen can't be the central atom. Carbon has to be, so that makes it pretty quick and simple. One other rule that you need to watch out for as well is that any halogen, so any element in group 7, the halogen family, also cannot be a central atom. They must be around the peripheries, or what we call a peripheral atom. And so for this diagram, I'm going to write out what my central atom is first. So that's carbon. It goes just somewhere on the page where you have room to write stuff around it. Now, the next rule is once I've identified what my central atom is and I write it down, then I'm going to attach all of the rest of the atoms, the peripheral atoms, around that central atom using 2 electrons for that purpose. So I go 2 electrons here like this, and then I attach a hydrogen around it. And then I just work my way around the carbon. And I want to place these peripheral atoms around the central atom, or atoms, as symmetrically as possible. And for this one, that's pretty easy because I can just get a hydrogen on each side of the carbon and I'm done. So now I look at this and I ask myself, okay, are the octets full for each of these atoms? So I take a look. This carbon, it has to have an octet that's full of 8 electrons, and so carbon has to have 8 electrons surrounding it or around it. So I count them, 2, 4, 6, 8. Carbon has a full octet. I then also now need to check the octets of the peripheral atoms. Now, hydrogen, remember from the previous video, is a special one. It only has 2 electrons to fill its octet. And so I don't want to have any more than that, and I don't want to have any less than that. So I look and I see hydrogen's got 2, that's good. This hydrogen's got 2, this one's got 2, and this one's got 2. So this diagram is finished. If all the octets are full for the diagram, then you know you're done. If the answer is no, not all the octets are full, then you move to the next rule. And so I've got some other examples here that we'll run through, and I'll show you how to draw each of these, illustrating each of these rules where we would say, okay, no, the octets are not full of these particular atoms, so then what would I do at that point? But for this diagram, this guy is finished. That's the electron dot diagram. Now, if I want to draw the structural diagram for this, which is also something that you need to know how to do, then each pair of electrons, so for every 2 electrons, we would replace that with 1 line or 1 stick, we oftentimes like to call it. And so the structural diagram would look just simply like that. Okay, so let's move on to our next example and illustrate some of these other rules. Again, rule number 1, we got to count how many valence electrons we have. So I know I've got 4 for this carbon, and I know fluorine is in group 7, so it has 7 valence electrons, and I have 4 of those. So 7 times 4 is going to give me 28. And so 4 plus 28 gives me a total of 32 valence electrons to work with, which is quite a bit more than the previous example. So now I identify what is my central atom. Again, carbon is present, that's pretty easy, carbon goes in the middle. Fluorine is a halogen, it can't be in the middle, so I know it goes around the outside. And then again, the next rule is just place the peripheral atoms around the central atom as symmetrically as possible. So that's good. Now I look at this and I say, okay, I've used up 8 electrons here, but I have way more than 8. And I have to find a place for every valence electron in these diagrams. And so out of these 32, I've used 8, which means I'm going to have 24 electrons left over. And so now what do I do? Well, first I got to check the octets. I can see the carbon octet is full, it's got 8. But these fluorines only have 2 electrons, and it's not like hydrogen where it has a full octet with only 2 electrons. Fluorine also has to have 8 electrons. So the next rule is I fill the octets of the peripheral atoms first with any remaining electrons that I might have. Here I've got 24, so I'm just going to go ahead and fill the octets of the fluorines. And I'll just do each fluorine at a time. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So of these 24, I've used all 24. I have 0. And now once I'm at 0 electrons here, now I want to check my octets. So again, I know that the carbon octet is full. We've already established that. And then I look at the fluorines. This fluorine is full. You can see that you don't have to do this in your diagram, but I'm going to draw these circles just to illustrate something. You can see that this carbon has a full octet. It's got those 8 electrons. And this fluorine has a full octet. And so does this fluorine. And so does this one. And so does this one. And so what you can see here is that these electrons between the carbon and the fluorine are being shared. And if you remember from the previous video that we talked about covalent bonds are made when electrons are being shared. And so these electrons are shared between these two. And so that's our diagram. Now your Lewis diagrams or your electron dot diagrams do not include these circles, but sometimes I like to draw them in just as I'm kind of checking for my octets and then erase them when I don't need them. And then I can make a structural diagram out of this as well. Okay, so my structural diagram, again, I'm going to have 1 stick for every 2 electrons that are used in bonding here. And so my carbon tetrafluoride molecule would look like that for its structural diagram. Now for the first two examples, how do I establish or use Lewis symbols to show that my Lewis diagram is drawn correctly? Well, if you take a look and you remember that carbon, its Lewis symbol looked like that, and hydrogen, its Lewis symbol looked like that. So carbon has 4 bonding electrons and hydrogen has 1 bonding electron. And so what I want to confirm here in my diagram is, okay, I'm using the Lewis symbol to make sure that the carbon has 4 bonding sites, or 4 places where I would have sticks coming off of it. And I can see that that's the case in this diagram right here. Carbon has a bond, a covalent bond here, 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 and here. So it's got 4 sites where it's got bonding occurring, and that fits this diagram. Hydrogen has 1 bonding electron, which means it only has 1 place where bonding can occur. And you can see that that also is true in this diagram. So using the Lewis symbols, you can see how I can confirm that my Lewis diagram probably is what it's supposed to be. If you also look at this one right here, the carbon tetrafluoride, the same is also true. 4 bonding sites, 4 sticks around the carbon. And then for the fluorine, it's got 7 valence electrons, and so you can see that it only has 1 bonding electron. Again, only 1 bonding site, and so it should only have 1 stick coming off of it. In this case, it does, and so I know I'm good. And those diagrams are accurate. So that's how I would kind of use Lewis symbols to confirm what I'm doing. All right, so let's take a look at our next example and our next set of rules. So our next example here is going to be NH3, or ammonia. Come over here a little bit. So I go to the periodic table, count up my valence electrons. This has 5. This has 1 for the 3 of them, so there's going to be 3. So 5 plus 3 is 8 valence electrons altogether that I have to build this diagram. Now, I know that there's no carbon here this time, but I know that hydrogen cannot be a central atom. So my central atom for this has to be nitrogen. And then I'm going to place the other atoms, the peripheral atoms, around symmetrically as possible. Now, in this case, I can't put them around exactly symmetrically. That's okay. I just put them around as symmetrically as possible. So I would draw it something like this. If you decided to draw it like this, that's also okay. It's not a huge deal for these diagrams. So I take a look here, and so far I've used 2, 4, 6 of my 8 valence electrons. Oops. And so how many do I have left over? I've got 2 electrons left over to make this diagram. Now the next rule states that if the octets are not full, then I'm going to place electrons around the peripheral atoms first. But if you take a look at the octets, you can see that the hydrogens already have a full octet, so I don't want to add any more electrons to them. So if the octets are not full, and I can't place them around peripheral atoms, then the next option is I place them on the central atoms. And you can see here nitrogen has a spot where I can put those electrons. And so those are going to go right there. And that, as you can see, brings me to my total of 0. And so now I'm going to check electrons, or check octets, and again I've established that hydrogen's already full, and you can see that nitrogen also has 8 around it, so its octet is full, and so now that diagram is done. I want to draw my structural diagram for this. The structural diagram has sticks. My structural diagram looks like that. Now, one sort of side rule when we're writing structural diagrams is that if a central atom has a lone pair, you can see this lone pair here is not involved in bonding, it's not attached to anything. Any lone pairs that are found on central atoms must be preserved in the structural diagram. So when I draw my structural diagram, I need to make sure that that nitrogen contains and has those 2 electrons in that orbital that's not involved in bonding. And again, if you want to use Lewis symbols, you can use Lewis symbols to confirm your diagram. We know that nitrogen has 5 valence electrons, so I would draw its Lewis symbol like that. And you can see that nitrogen has 3 bonding electrons, so it should have 3 sticks coming off of it, and it does, so this confirms our diagram. Okay, so my next example is going to be carbon dioxide. Carbon dioxide has a carbon and 2 oxygens. That's going to give me 4 plus 6 plus 6, which is 12. So 4 plus 12 is 16 electrons. And that's the number of valence electrons that I have to build this. I know carbon is going to be in the middle, and I want to place the oxygens around the carbon as symmetrically as possible. So I'm going to put 1 on each side, kind of like that. Now I've used 4 of the 16. That means I have 12 electrons left. And if I do the next rule, which is placing the electrons around the peripheral atoms that don't have full octets, I look at this, neither the carbon nor the oxygen have full octets. So I'm going to definitely put those around the oxygens first. So 2, 4, 6, 8, 10, 12. And I just fill each peripheral atom as I go. And so you can see I've got 12, I'm at 0. So now my rule here is I'm going to check the octets to make sure that my diagram, every atom in the diagram has a full octet. I look at the oxygens, those octets are full, but I look at the carbons, and the carbon only has, or I look at the carbon, the carbon only has 4 electrons in its octet, and that's not full. So I have a problem here. So what's the next rule? Well, the next rule is I need to share electrons from the peripheral atoms in towards the central atoms in order to fill the octet. I can't just miraculously pull more electrons out of my total here because I don't have any. I can't add electrons in here to just fill the octet because I want to. I have to work with however many electrons I have to build the diagram. And so I'm out of electrons, which means now I need to share more electrons towards the middle. So I can take any one of these 3 lone pairs and share it in towards the middle. And again, what I want to do is I want to keep the diagram as symmetrical as possible. And so it doesn't matter, I could take this one, or this one. It doesn't matter which one you want to pull in, but you take that, let's say that lone pair there, and I'm going to move it in towards the middle, shared now between the carbon and the oxygen. And I'm also going to do that with this one. So now you can see this carbon has 8 electrons around it, and these oxygens still have their 8 electrons around it. And so if I want to draw my Lewis diagram for this, or sorry, that is my Lewis diagram, my structural diagram, I've got 2 pairs of electrons now, not just 1 pair, but 2 pairs between the carbon and the oxygen. So that warrants 2 sticks, or a double bond is what we call that. And so you can see that the structural diagram for carbon dioxide contains 2 double bonds between the carbon and the oxygens that are found in that molecule. Again, you can see that these peripheral atoms here have lone pairs on them in the electron dot diagram. For the structural diagram, it's not necessary to put those in. The carbon here does not have any lone pairs on top or on the bottom, so there's nothing to put on the top or the bottom for that diagram there. And so that's carbon dioxide, and that's the next rule, is you have to be able to share electrons from the peripheral atoms in towards the middle. Now the last diagram that you need to be able to draw are ions. Now all the rules apply when drawing these. So I go ahead and I say, okay, I've got 3 valence electrons here, 6 for oxygen. That gives me 9 valence electrons altogether, but this is a positively charged ion, which means it has 1 less electron. And so instead of 9 valence electrons here, I have to actually subtract 1 electron out of that because this has a positive charge. Now, if you were drawing something like this, like the carbonate ion, then when you would total this up, you would add 2 electrons to that. But for this one, it's a positive charge, so I've got to subtract an electron out. So I have a total of 8 electrons to work with to build this diagram. I know that hydrogen cannot be the central atom, so oxygen must be. Oxygen goes in the middle. I place the peripheral atoms around as symmetrically as possible. I've got 3 of them. 2, 4, 6 is what I've used. I have 2 electrons left. I can't place them around the peripheral atoms. Their octets are already full, so I'm going to place it on the central atom, just like that. And now I'm at 0. I'm going to check the octets to make sure they're all full. I look and I see that oxygen is also full, and so I know my diagram is finished. And so when my diagram is done, for the ones that have charges on them, you must stick these square brackets around the diagram and then stick a positive, stick the charge that it has on the outside of those brackets. For this molecule here, it has a 1 positive charge, so I just stick the positive sign on the outside, just like that. And then if I were to draw my structural diagram, same thing. It gets square brackets around it, and I make sure that that lone pair is placed on the central atom because it's here on the central atom in this diagram, and that's what my structural diagram looks like for that. So again, guys, take a look at the video description down below for the rules, the written out rules. Make sure you have those in your notes so that you can refer to them as you go through your practice, and good luck as you do that. Thanks for watching.